Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
In the third quarter of 1977, history was made when the twin space probes, Voyager 1 and Voyager 2, were launched into space. With the probes being sent forth with one mission to explore the mysteries of our solar system, little did anyone know these mechanical marvels would far exceed expectations. From Jupiter to Uranus, the probes have explored the major outer planets, and now, having gone beyond our solar system, the Voyager 1 seems to have picked up something terrifying in the uncharted realms of interstellar space as it unexpectedly turned backward. Why did it turn back, and what does this mean? How does it affect our understanding of space? Join us on this fascinating journey of space exploration to find out. The one-way express around the solar system. The 20th century came with a lot of questions and a hunger for knowledge. One was the search for comprehensive knowledge about our solar systems and the planets therein. It was believed that right when we become fully aware of the planetary bodies around us, we'd be a tad bit closer to unveiling the secrets of the cosmos. This journey of discovery had already begun with the Apollo missions, which demonstrated humanity's ability to go beyond Earth. However, it soon became clear that manned space missions were resource-demanding and not always feasible. This realization paved the way for the robotic missions to come in. The robotic missions by NASA all started with NASA's Mariners. The only problem was that they were built for short-duration trips to a particular planet, which made them a little bit ineffective. Eventually, the narrative changed with the invention of the Voyagers. The Voyagers were built for one sole purpose: to surpass the limits of the Mariners, and they were able to do so by staying much longer in space. Generally, this gave us a larger window to not just study the planets, but to compare their characteristics. However, the space probes didn't stop at their mission. Even after they had accomplished their mission, they continued to go even further, revealing terrifying celestial bodies we had never imagined. For a feat quite grande, this begs for reasoning, starting with thoughts like how these robots came to transform the space exploratory journey. Let's break it down together, starting from the very first line of thought that led to its invention. Since the beginning of the space journey, the idea has always been to surpass all human limitations. From the launch of Sputnik 1 to the advent of the Voyagers, each step has required visionary thinking from a single person willing to redefine the odds. This is what has led to the series of scientific breakthroughs that have benefited humanity as a whole. The very same can be thought of by the Voyagers. It took a single man, Gary Flandreau, to conceive the idea of a space probe. Not just any space probe, the Voyagers, one of man's very first mechanical construction to travel several astronomical units away from our solar system. So, what about the man? What made him a genius? Well, right before Gary's discovery, he was already deeply involved in space science as an American aerospace engineer. Things were even much easier due to the fact that he had gotten his BS in mechanical engineering and his master's in aeronautics from the California Institute of Technology. As a matter of fact, it was in the mid-1960s, during the time he was working at NASA's Jet Propulsion Laboratory, that Flandreau got his idea for the project. He was able to identify an unusual phenomenon in space where the planets like Jupiter, Saturn, Uranus, and Neptune align. For a phenomenon so rare, NASA eventually came to learn that the alignment happened just once every 176 years. This event they called syzygy. If you're wondering about the relation that this phenomenon has to do with the Voyagers, you should know that the Voyagers were built solely to harness the power of the alignment of the planets. Apparently, right when the planets come together in a straight line, a gravity slingshot is created. Flandreau thought that if we could make good use of this celestial power, we would be able to catapult our spacecrafts further into space in less time.
That I could get to Neptune in 7 or 8 years by going Earth, Jupiter, Saturn, Uranus, Neptune, using what's called the slingshot method where the gravity of each of those planets pulls you along and adds energy, makes you go faster. You can do some amazing things with that.
This was how he ended up submitting his proposal for the Grand Tour. Being that NASA was willing to test the theory, it wasn't long before they started building the Voyager. The construction of the Voyager spacecraft was truly one of a kind, posing as one of the markers of engineering ingenuity. For NASA, in accordance with Flandreau's proposal, their goal was to create a spacecraft capable of not just withstanding harsh conditions in space, but also withstand extensive gravitational pull for a long period. Working to build 2 of these identical spacecraft in the lab simultaneously, they equipped each of them with advanced scientific instruments that would study atmospheres, moons, magnetospheres, and rings of the outer planets. The instruments include spectrometers, plasma detectors, and a few other advanced instruments that you most likely wouldn't see so casually. Furthermore, to ensure the longevity of the mission, they installed a radioisotope thermoelectric generator whose aim is to convert heat from the decay of plutonium-238 into electricity. This way, the space probes are bound to have a long supply of electricity. Then, of course, we could talk about the designs, the components, and the onboard computer system. Everything was meticulously chosen for one sole reason: the success of the mission. The 176th year that the alignment of the planets was bound to happen arrived. This time, it fell under the year 1977. The 2 space probes that were bound to leave Earth were named according to their speed of departure. For the first one, which happened to be Voyager 2, scheduled for departure on August 20th, it was the slowest of the space probes. This was because it was launched a little bit sooner before the alignment of the planets. Voyager 1, which was launched in September of the same year, was the fastest of the twin space probes. At the time it was launched, the planets were in perfect alignment with each other, hence contributing to the speed of the spacecraft. After departing Cape Canaveral, Florida, and upon entry into space, NASA watched Gary Flandreau's theory come to reality. As the Voyagers got close to each planet, they fell into the planet's gravitational well and gained speed. Thanks to the model behind their construction, it was pretty easy for NASA to navigate the spacecraft so they didn't end up crashing. Take, for instance, Voyager 2, which is a journey around Jupiter. The planet's immense gravity accelerated the probe and directed it towards Saturn. And then, a similar process occurred further, moving the Voyager 2 towards Uranus and then Neptune. It was more like a flyby across planets if anything like that existed. The Voyager will first visit, slow down, gather data, and speedily move to the next planet. At this rate, the spacecraft didn't just beat the speed of their predecessors, they stayed on course throughout their journey. This accomplishment proved that Gary Flandreau's calculations, predictions, and theory were all correct and precise. It turns out that from the very first day they entered space, these mechanical constructions have not been idle, as they've discovered quite a lot already. What did they discover? Stay tuned. You are about to know all that NASA has learned from the Voyagers in the past decade. Think of it more as a precautionary measure, one based on probability, considering the various chances and shots the space probes have. You can say from the onset, NASA was ready for any casualty. Little did they know that both the Voyager 1 and 2 would make it this far into the future without falling apart. As a matter of fact, in the course of their journey, the Voyagers have sent a treasure trove of knowledge down to Earth. And this knowledge has done more than broaden our knowledge about the solar system. It all started with Voyager 1. Even though it was launched lastly, it overcame Voyager 2 to become the first to reach Jupiter and Saturn. Apparently, for the planet Jupiter, Voyager 1 had arrived precisely in January 1979. It showed proof of its arrival to the world by capturing the very first detailed images of the atmosphere of the planet. There, we were able to capture not just complex cloud structures, but also severe storms that went a long way to show the instability of Jupiter's atmosphere. NASA named the storm the Great Red Spot. What's more, the Voyager also discovered volcanic activity on one of Jupiter's moons, the very first time man got to see an active volcano in another place aside from Earth. This discovery reshaped our mindset, leading NASA to look out for more similarities between Earth and the other planets. All these while Voyager 1 was touring around Jupiter, Voyager 2 followed closely in a different trajectory. It arrived 6 months later to complement Voyager 1's discoveries by capturing more data on the planet's magnetosphere and the Moon. And then afterward, it was time for Saturn. Voyager 2's arrival to Saturn in August 1981 was yet another milestone in the Grand Tour. This time, the Voyagers took shots of Saturn's rings, which had long fascinated scientists up close. Thanks to Voyager, we were able to learn that the planet's ring isn't just one ring, but a complex ring system comprising countless particles of different sizes. They all orbited around Saturn, which was covered with a mixture of water, ice, dust, and other chemical compounds. To help classify these rings, each was designated a letter up to G, depending on those that diffused more. Voyager data also captured the presence of ringlets and gaps within the rings, such as the Cassini division, which is a large dark gap between the A and B rings. Besides the large gap, there is also the narrower part known as the Encke gap, and of course, the spokes. These are all distinct features that set Saturn apart from the other planets. However, even though seeing the ring system was quite spectacular, it didn't compare to the sight of the planet's largest moon, Titan. We learned that the moon is basically an orange haze of methane and nitrogen, and it has plains, polar lakes, and seas filled with liquid hydrocarbons. What is fascinating about this landscape is that, regardless of the sea of hydrocarbons, the surface of the moon was frozen, having a temperature almost below minus 290 degrees Fahrenheit, one of the coldest regions in our solar system. Due to the complex nature of the moon, NASA and other astronomers are considering the chances of there being extraterrestrial life on Titan. However, the theory is yet to be confirmed, as there have been no signs pointing at the presence of life. Fascinating, right? Even after accomplishing all that, the Voyagers didn't tarry in their journey. It's true that Voyager 1 slowed down after visiting Titan. However, Voyager 2 was right on track to pick up the pace this time. This was how Voyager 2 became the very first among the twin space probes to visit Uranus and Neptune on January 24th, 1986 and August 25th, 1989, respectively. Like the other planets before, Voyager 2 covered quite a lot about Uranus. It discovered 10 new moons, 2 new rings, and a magnetic field that tilted significantly from the planet's rotational axis. In general, the findings were just as complex as the previous planet that the Voyager 2 had visited. It was far from dormant as astronomers had predicted, and it had several features to show for it. Voyager 2's journey to Neptune was even more mind-boggling as scientists got to see the Great Dark Spot, a massive storm that looked exactly like Jupiter's Great Red Spot. It is believed that the moons on the planet just might have something to do with the storm on this planet. To this day, astronomers and scientists continue to study these storms, looking for their possible causes. It's only a matter of time before the reason is found. While Voyager 2 was busy, its twin, Voyager 1, decided to take a new route and head towards the edge of the solar system. Initially, Voyager 1's new route did call for concern. However, thanks to the pale blue dot picture it took of Earth from a distance of 3.7 billion miles away, we were glad it did. The picture didn't just provide the most iconic image of 1990, it reminded us of how insignificant we appeared in the eye of the universe. For a planet that appears to be a speck of dust from a billion miles away, it goes a long way to tell that we are yet to unveil even a fraction of the secrets that lie in the universe. Wouldn't you say? After the space probes had surveyed the planets up to Neptune, The mission was tagged successful. At that point, NASA was willing to look for a means to call back the legendary space probes, or at least shut it down. However, Carl Sagan, an influential American astronomer, shunned the idea. He convinced the body that they should leave the space probes active, watching them exert themselves beyond their limits. For Carl Sagan, he still had expectations for the probes, and it turned out his expectations were not cut short. Deep Space Network, the body behind the Voyagers. When we talk about the challenges that the Voyagers faced during the Grand Tour, they did face quite a lot. From space storms to micrometeoroid showers and extreme temperatures, it most likely took the strong will of man for these space probes to make it through. However, that zeal and determination were extinguished the very day that the operators at Deep Space Network noticed a loop in the info that Voyager 1 was sending back to Earth. You might probably be wondering or asking, who or what is the Deep Space Network? They are a body cut out by NASA to handle communication between the Voyagers, other distant satellites, and Earth. In other words, they ensure that we maintain contact with our faraway space explorers, closing up the gap in distance. The DSN is able to do this thanks to the 70-meter-wide gigantic satellite dishes, which are positioned at strategic places like California, Madrid, Goldstone, Spain, Canberra, and Australia. These locations come together to triangulate communication, hence magnifying the low signals that come to Earth. Talking about the signals gotten from the Voyagers, they come mostly as faint signals right before they are magnified by the satellite dishes. Even after that, the signals are converted into binary codes involving ones and zeros. It takes not just highly skilled personnel to translate these codes to readable data, but they have to imbibe the help of modern computers as well. That wasn't the case back in the day. In the past, the DSN dealt with strict binary codes and nothing more. For the major challenge, which was the loop of information, it turns out that it was during one of the transmission sessions that DSN got to notice. Apparently, this loop had been on for a while, but only when NASA compared past data did they get to see the similarities. As a means to fix things, they reverted to several manuals written by the past creators to fix the space probe. However, it has proven quite unfixable, a testimony to all the hardship that the space probe had undergone in the past years. Looking at the state of Voyager 1, there are several things that are possible. One could be that either one of the chips in the computer got fried, or it could be because the space probe has overworked itself in the past years. Whichever the cause of the problem might be, it doesn't explain Stella Koch's discovery. During one of her supervisions, she noticed that there was a scary hum coming from the Voyager. While some speculate that this might be a signal from another civilization, others think it might be from the computer on board. To this day, the hum remains a mystery. It might interest you to know that just like the Voyager 1, the Voyager 2 also experienced its own technical issues. At a time, it was impossible to communicate with the space probe. However, the problem was fixed by the engineers later. Even though we can't pitch both problems as the same, it's most likely that NASA left Voyager 1 in hopes that the space probe might still have juice to feed us with viable information. Whether that happens or not, we can clearly say that history has been made by these 20th century contraptions. With us now looking at the Voyager 2 as the only possible means to study interstellar space, do you think the space probe would outlive its twin? Tell us all about your expectations in the comments section. We hope to see you at the next one. Bye.